Welcome to the debate. So picture this. You're walking down the street on a Tuesday afternoon.
Just a regular Tuesday.
Right, just a normal Tuesday. And before you even consciously realize you're hungry, an app on your phone pings you. It offers a discount for a taco stand, maybe just 100 feet away.
Highly convenient.
Exactly. It feels like a stroke of luck or, a helpful nudge. But what if the math behind that ping didn't just know your location? What if it knew exactly how many times you paused while scrolling food apps that morning?
Yeah, and it cross-references your current stride rate.
Yes, and it calculates that your specific willpower to resist an impulse purchase is at that exact moment at its absolute lowest point of the week.
Which is exactly the reality we are living in right now. I mean, when we think about human decision-making, we have this deep-seated expectation of spontaneity.
We like our freedom.
Right. We like to believe our lives are like an improvisational jazz performance. You wake up, you feel the mood of the morning, and you choose a path that is entirely your own. But step into the architecture of modern, algorithmic behavioral prediction,
Which we are going to do today.
and that jazz performance starts looking remarkably like a player piano.
Which brings us to the very core of our discussion. For everyone studying digital ethics right now, this really is the defining tension of our era. The question is, does the unprecedented systemic efficiency gained by AI's behavioral prediction pipelines outweigh the profound risks those systems pose to human agency and privacy?
It's a massive question.
It is. We're looking at mathematical architectures that construct a comprehensive behavioral genome for every user, taking everything from, keystroke dynamics to geolocation to forecast our actions. Now, I take the position that these predictive models are absolutely essential engines of global optimization.
Well, I'm sure you do.
I do. They are not the enemy. I mean, they are mathematical triumphs that transform chaotic, overwhelming data into the life-saving and, frankly, resource-saving efficiencies that modern society desperately needs to function.
And I take the position that this relentless pursuit of optimization relies on an invasive, deterministic dissection of the human psyche.
Invasive is a strong word.
But it's accurate, reducing our human quirks or hesitations and our distinct behaviors into quantifiable levers creates a system inherently ripe for manipulation. It crosses a line from observation into surveillance. It's the fundamental erosion of free will, really, turning our most private internal states into mere probabilistic variables for algorithmic exploitation.
Okay, to understand why I see this as a triumph, we need to look under the hood at how these predictive pipelines actually work, because this isn't magic. It is a victory of mathematics over chaos.
Math can be chaotic too.
Sure, but we are talking about utilizing tools like recurrent neural networks, specifically long short-term memory networks, or LSTMs.
Right.
To break that down for our digital ethics students, an LSTM doesn't just look at a single action in isolation. It has a memory loop. It captures sequential dependencies.
Right. It remembers.
Exactly. Think of it like reading a book. You only understand chapter 3 because you remember chapter 2. If you start a commute in Tokyo, the LSTM maintains an evolving state of your journey, continuously updating predictions to smooth out your arrival based on transit delays or weather.
Yeah, and it pairs that with other architectures to build a complete profile,
Exactly. It uses self-attention transformers.
which are fascinating but also terrifying.
Terrifying? No, what a transformer does is weigh the relevance of your entire history simultaneously. It understands that your search for nearby tacos in Los Angeles relates strongly to your past Mexican food logs. It doesn't treat it like a random, isolated query, and the macro-level benefits of this technology are just staggering.
If you only look at the macro level, maybe.
Well, look at the disaster response models. We have models that orchestrate safe evacuations from habituated routes in the typhoon-prone Philippines because they can predict exactly how populations will move.
Yes, but
Wait, let me finish the thought. We have energy grids in India preempting massive power peaks because they mathematically anticipate regional dinner cooking times. Epidemiology models tracking mobility behaviors to prevent viral outbreaks in dense Asian cities before a single hospital is overwhelmed. I mean, this predictive efficiency is a moral imperative. It makes highly complex global systems sustainable.
the macro-level examples you're giving, the typhoon evacuations, power grids, those are the benevolent applications. They are the shiny surface.
They're real-world applications.
But you have to consider the cost of that efficiency on an individual level. This optimization relies on parsing human behavior into psychological vulnerabilities. The AI doesn't just passively observe traffic patterns, right? It actively clusters individuals using Gaussian mixture models.
But clustering is just a way to organize data so it can be useful. It's categorization.
It is how it organizes the data that matters. A Gaussian mixture model doesn't just put you in a rigid box. It calculates the exact probability that you belong to multiple overlapping psychological profiles.
Which makes it more nuanced.
It groups impulsive buyers in Middle Eastern bazaars alongside methodical planners buying Swiss watches. And it fuels this model not with demographics, but with micro-behaviors.
Micro-behaviors are just data points.
We are talking about algorithms measuring the literal millisecond of a hesitant pause before tipping a street vendor in Bogota. We're analyzing rising voice inflections during a negotiation in Brazil. When a system monetizes your hesitation, it has crossed the line from logistical observation into active manipulation. It builds archetypes specifically to exploit us.
Okay, I think we need to carefully define what we mean by manipulation versus observation here. Let's look at the nature of data collection itself.
Gladly.
I frame this data collection as contextual feature engineering. It is fundamentally neutral.
Neutral.
Yes, neutral. A system tracks a sequence of morning jogs in Sydney parks to predict a weekend trail run. Or it uses IoT fridge sensors in a smart home in Singapore to anticipate grocery chores. This is simply a machine layering environmental reality to smooth out the friction of daily life.
It's not just smoothing friction.
It applies mathematical concepts like exponential decay, which, just means it weights your recent events more heavily than things you did 5 years ago.
It is purely context. There is absolutely nothing neutral about measuring the exact millisecond of hesitation before I click a button. You call it contextual feature engineering. I call it intimate psychological profiling.
That's a bit dramatic.
Is it? Let's look at how this behavioral genome is actually constructed from those multifaceted data streams. When a system measures rapid keystroke bursts in a Tokyo office, it isn't just tracking typing speed. It is running that cadence through an algorithm to deduce a psychological state of urgency or stress.
To offer help, perhaps.
When it analyzes mouse entropy, meaning how erratic your cursor movements are, it is actively trying to quantify your state of mind. It contrasts the erratic, wandering mouse paths of a user in Istanbul, labeling it impulsive exploration, against the highly linear, efficient scans of a methodical engineer in Germany.
But why is that inherently sinister? Let's ground this in a real-world physical equivalent.
Okay.
Isn't an AI noting your mouse movements or your swipe entropy just the digital equivalent of a shopkeeper noticing a customer pacing the aisles?
No, it's really not.
Hear me out. If you're in a bookstore and you look hesitant, pacing back and forth, and the shopkeeper walks up and says, can I help you find something? We call that excellent customer service. Why does scaling this observation mathematically suddenly make it a violation of human agency?
Because the scale changes the nature of the interaction.
We are using logistic regression baselines that scale up to multi-class choices via softmax functions, which is just a fancy way of saying the math converts all your possible choices into a tidy list of probabilities. It is just a highly observant shopkeeper.
The shopkeeper analogy fundamentally breaks down the moment you introduce the scale, the memory, and the synthesis of the machine.
I disagree.
A shopkeeper doesn't follow you home. A shopkeeper doesn't cross-reference your pacing with your heart rate from your smartwatch, your past 5 years of credit card transactions, and the real-time purchasing behavior of your entire social network.
Well, they would if they could.
But they can't. The AI uses multimodal fusion. It employs computer vision to decode furrowed brows and Paris fashionistas, and sensor fusion via Kalman filters to blend incredibly noisy signals into a holistic, inescapable portrait of who you are. The shopkeeper goes to sleep and forgets you by Tuesday.
True.
The algorithm never forgets. It uses your pacing to assign you psychometric score using item response theory, effectively locking you into a behavioral archetype forever.
Even if the algorithm has perfect memory, if that perfect memory allows it to serve you perfectly, the user still benefits.
Do they?
Yes! Let's talk about how this genome is applied to real-time adaptation, because this is where the system actively works for the user.
We have incredibly sophisticated tools operating here, like bandit algorithms.
which are explicitly designed to maximize the platform's reward, not the users.
They maximize mutual reward. Take Thompson sampling, a specific type of bandit algorithm. Imagine you are at a casino, deciding whether to keep pulling the slot machine you know pays out occasionally. That's exploiting. Or trying a brand new machine you've never touched. That's exploring.
Right, the exploration-exploitation dilemma.
Exactly. Thompson sampling is the math behind perfectly balancing exploration and exploitation. In practice, this means an app can test new, spicy restaurant nudges for an adventurous diner in Bangkok, while sticking to safe, familiar favorites for a conservative eater in Vienna.
It's testing them.
It provides preemptive assistance. Look at autonomous transport systems, predicting pedestrian crossings in crowded Delhi streets. The AI anticipates a person stepping off the curb before they even move, yielding a safer path. The application of this knowledge protects people.
You are taking the most benevolent physical examples like pedestrian safety and using them to shield the behavioral science exploitation happening under the exact same mathematical hood in the digital space.
I'm not shielding anything. I'm showing the utility of the math.
The reality is that these bandit algorithms are often used to test how much a user can be squeezed. These models actively deploy prospect theory and loss aversion against human beings.
That's a strong accusation.
Look at retail traders in Dubai markets. Algorithms are designed to exploit their cognitive bias against taking a loss, nudging them in ways that keep them engaged even as they bleed money.
That is an abuse of the system, not the purpose of the architecture.
It is the intended function of an optimization engine built for engagement. Look at Hawk's processes. Think of a Hawk's process like an earthquake with aftershocks. The math predicts how one event increases the probability of subsequent events.
Yes, clustering in time.
Exactly. In South Korea, platforms use Hawk's processes so that one impulse buy mathematically triggers an engineered chain reaction of consumerism. They time the next notification precisely when you are most vulnerable to a second purchase. This isn't preemptive assistance. It is persuasion masked as convenience.
It's just smart marketing.
They are leveraging Charles Duhigg's cue response reward habit loops to trigger behaviors.
I push back heavily on the idea that these interventions are inherently coercive or hostile. Let's look at intention. If a system can predict and prevent an abandoned shopping cart in Berlin by offering a timely 10% discount, the user saves money and the business makes a sale. Or consider a health app.
Oh, the fitness nudges again.
Yes. If it can nudge a fitness lax user in Spain to put on their running shoes just 20 minutes before they typically skip their routine, isn't that system actively helping the user achieve their own stated goals?
But
If the user downloaded the fitness app, they want the nudge. How do we distinguish between what you call an algorithmic trap and what is simply a highly effective, beneficial guardrail?
the distinction lies entirely in who sets the ultimate objective function and the power dynamic of the math being used. Yes, the user wants to work out, but does the user in Berlin genuinely want those abandoned sneakers, or are they being mathematically coerced into completing a transaction during a moment of predicted cognitive depletion?
Coerced is a big word for a discount code.
Let me explain how deep this goes. The AI uses survival analysis, specifically Cox proportional hazards. Originally, this was medical math used to predict patient survival rates or the time until a machine part fails.
Right, time to event models.
Now, consumer platforms use Cox proportional hazards to calculate the precise time to action for your willpower to fail. They calculate the exact minute your resistance to buying those sneakers dies.
They estimate probabilities.
When a system understands your cognitive vulnerabilities better than you do and times its intervention for the millisecond you are weakest, a guardrail becomes a deterministic track you cannot step off of.
Calling it a deterministic track implies that human beings are entirely stripped of agency the moment an algorithm makes a prediction.
We are certainly compromised.
But the structural mechanics of these models actually account for free will through constant iteration. The models know they aren't perfect. They are probabilistic, not absolute. They calculate the likelihood of an action, and if you choose differently, the system self-corrects and learns from your deviation.
They might attempt to self-correct, but they are fundamentally, structurally flawed by bias and overfitting. They chase statistical noise and mistake it for human intent.
All models have noise.
These deterministic lenses fail catastrophically during novel scenarios. When the global pandemic hit and human routines were disrupted worldwide, these predictive pipelines broke down completely because they suffer from black swan insensitivity. They mathematically ignore the extreme tails of the distribution.
Which they eventually adjusted for.
But more dangerously, these biases amplify from skewed data. We see Western-heavy training models faltering entirely when trying to predict collectivist Asian actions. They severely mismodel understudied indigenous behaviors in Amazonia.
So we need better data representation.
When you force incredibly diverse, nuanced global populations into a mathematically rigid behavioral genome optimized in Silicon Valley, you aren't optimizing society. You are enforcing a homogeneous standard of normal behavior and entrenching inequities.
It is true that early models struggled with demographic bias, but the mathematics of the field are actively evolving to solve this. We are deploying causal inference.
Causal inference.
Yes, instead of just looking at raw correlation, we use propensity scores. Propensity matching is a statistical technique that untangles the variables. It helps the AI figure out, for example, if you bought the umbrella specifically because the app nudged you or simply because it was raining and you would have bought it anyway.
That doesn't fix the core issue.
It isolates the true cause and effect. Furthermore, we have robust systemic defenses being implemented right now.
Defenses built by the same organizations profiting from the tracking.
Defense is driven by rigorous computer science. We are moving toward federated learning paradigms. In a federated system, the machine learning happens locally on your physical device. The raw data of your hesitations, your typing speed, your location, it never leaves your phone.
Only the weights are sent.
Right. Only the mathematically encrypted, updated weights of the model are sent to the cloud. We are layering privacy-preserving techniques like differential noise, which intentionally injects random data into the set to cloak individuals within aggregates. It makes it mathematically impossible to reverse engineer your specific identity.
Assuming the differential privacy budget is set correctly.
And we are seeing massive regulatory frameworks, like China's PPIL or Europe's GDPR, forcefully curbing misuse. Instead of abandoning the incredible power of the predictive engine, we should be demanding explainable AI tools that make the math transparent.
I approach this from an entirely different angle. The mathematical calibration phase you are describing, where models learn from their mistakes and refine their propensity scores, isn't a victimless laboratory experiment.
Progress takes iteration.
Real human beings are harmed while the model is busy self-correcting. When HR analytics software predicts employee turnover based on the semantic tonalities of emails sent by multinational firm employees, and someone loses their job trajectory because an AI misread their tone, that is not a mathematical hiccup.
It's an edge case.
When surveillance algorithms chill free expression in monitored regimes because citizens know their every digital twitch is being scored, that is a profound loss of liberty. Explainable AI is a step forward, sure, but giving me a transparent dashboard that perfectly explains exactly how the machine exploited my psychological vulnerabilities doesn't negate the fact that it did.
But you have to weigh those risks against what we would lose.
For digital ethics students, a healthy, unyielding skepticism is absolutely vital here. We must recognize that the relentless pursuit of this efficiency is largely driven by economics, not altruism. Highly accurate behavioral predictions yield billions of dollars in inventory and logistics savings for megacorporations like Amazon, Alibaba, and global supply chains.
Efficiency is profitable, yes.
The primary beneficiary of the behavioral genome is the architect of the model, not the user whose intimate data fuels it.
I disagree that the benefits don't reach the user, because those massive economic efficiencies absolutely trickle down into tangible public benefits. Cutting inventory waste isn't just about corporate profit. It massively reduces the environmental impact of manufacturing and shipping.
I'm not against reducing waste.
But you have to weigh those risks against what we would lose.
For digital ethics students, a healthy, unyielding skepticism is absolutely vital here. We must recognize that the relentless pursuit of this efficiency is largely driven by economics, not altruism. Highly accurate behavioral predictions yield billions of dollars in inventory and logistics savings for mega corporations like Amazon, Alibaba, and global supply chains.
Efficiency is profitable, yes.
The primary beneficiary of the behavioral genome is the architect of the model, not the user whose intimate data fuels it.
I disagree that the benefits don't reach the user, because those massive economic efficiencies absolutely trickle down into tangible public benefits. Cutting inventory waste isn't just about corporate profit. It massively reduces the environmental impact of manufacturing and shipping.
I'm not against reducing waste.
When urban planners use multimodal heat maps to optimize pedestrian flows in the crowded squares of Rome, they are making the cities safer and more livable for the everyday citizen. When agricultural AI predicts weather and behavioral routines to advise farmers in Kenyan fields, it dramatically improves crop yields and fights food insecurity.
Again, physical versus behavioral data.
The fusion of probabilistic forecasting and multimodal data is an indispensable tool. The sheer overwhelming complexity of modern civilization, with 8 billion people interacting globally, cannot be managed by intuition. Without these predictive pipelines, we revert to massive, chaotic inefficiencies that cost time, burn critical resources, and ultimately cost human lives.
And my position remains that treating humanity as a collection of predictable, optimizable archetypes invites a level of surveillance that fundamentally degrades what it means to be human.
Even if it saves lives.
Chill's spontaneous expression. It entrenches dark patterns into the very fabric of our digital infrastructure. It takes the vibrant, unpredictable jazz performance of a human life and flattens it into an optimized, monetized script.
That's very poetic.
The convenience of a preemptive traffic alert in Mexico City or a perfectly timed discount on running shoes in Berlin is simply not worth the sacrifice of our cognitive sovereignty. If we accept the premise that our every hesitation, our every voice inflection, and our every impulsive swipe is just raw material to be harvested and modeled, we surrender the very agency that defines us.
Well, as we draw this debate to a close, it is incredibly clear that we are navigating a razor-thin line here. We are balanced between unprecedented societal capability on one side and profound ethical risk to human agency on the other.
Very thin line.
While we fundamentally disagree on whether the global efficiency outweighs the potential for exploitation, our analysis does converge on a crucial point. Navigating this landscape safely requires extreme active vigilance.
Absolutely. This isn't a lost cause, provided we implement structural, uncompromising defenses. We need mandatory fairness audits to expose where algorithms are mathematically biased.
I agree with that.
We need user-facing behavioral dashboards that make the invisible, microscopic tracking entirely visible. And crucially, we must enforce strict data minimization, starving these models of the highly sensitive, totally unnecessary micro-behaviors that enable psychological manipulation in the first place.
We certainly have an obligation to protect users from the black box nature of these models. For everyone out there studying the intersection of technology and ethics, the ultimate question remains wide open for you to solve. How can society wield algorithmic awareness to benefit from AI's incredible power for global optimization without allowing the individual to become a mere probabilistic variable in its engine?
It requires maintaining a rigorous skepticism about who is actually doing the predicting, what their objective function is, and to what ultimate end.
Next time you catch yourself making a seemingly spontaneous decision, whether it is choosing a new route to work or reaching for an impulse purchase you suddenly feel you need, take a second to ask yourself, are you truly playing your own tune, or are you just hitting the notes perfectly predicted for you on a player piano? Thank you for joining us on The Debate. Keep questioning.